Basic electrical engineering. We are in the unit of insulating materials. In insulating material, we are studied the different type of insulating materials like solid insulating materials. In that, fibrous material, impregnated material, and PVC, rubber, mineral material, ceramic material, glass materials, and non-resinous material like that. Also, we will study the liquid insulating materials and gaseous insulating materials. In our previous class, we have learned about the impregnated paper and some type of mica products, asbestos, like that type of insulation materials we are studied. In continuation to that, the solid insulation materials also having another type, that is ceramic materials. This ceramic material is like porcelain, steatite, alumina, titanate, like those type of material. Ceramic materials are the materials made by high temperature firing treatment of natural. These can withstand very high temperatures. Ceramic materials are clay products which are made by high temperature firing treatment. They contain compounds of metallic and non-metallic elements. Structurally, ceramics are crystal bonded together. Ceramics used in engineering are porcelain, steatite, alumina, titania, like that. And other crystal materials used with clay in different types of ceramics are quartz also, talc, magnetite, like those type of materials. So overall, what we are observed in this type of ceramic material, this is a clay products. It can withstand very high temperatures up to 1500 degrees centigrade, like that. So in fire treatment, like those type of applications, these ceramic materials are used. They contain compound of metallic and non-metallic elements. Structurally, ceramic materials are crystalline bond together. Let's see what are the properties. Some of the properties is it is mechanically hard and strong, and its dielectric strength is 24 kV by mm. It can be easily molded to any shape. It is a non-hygroscopic, means it never absorbs any moisture or anything. So it is not affected by chemical action except by strong acid rains or strong acids and alkalis. It can withstand high temperature of about 1000 degrees to 1800 degrees centigrade. It can easily split into thin sheets. Its dielectric constants varies from 5 to 9.5. It has very high resistivity of the order of 10 to the power of 11 to 10 to the power of 16 ohm meters at 20 degrees centigrade. So what are the features we are observed in this ceramic type of material? Are these are very hard, strong and dense, not affected by any chemical action, and stronger in comparison to that remaining materials up to now what you are studied. So it is stronger in compression than tension, stability at high temperature, excellent dielectric properties. These are the different properties we are observed. Let's see what are the applications for this type of material. Due to desirable properties, the ceramic materials are used for many electrical applications. Ceramic Insulation materials are used for making insulators used in uh, transmission and distribution lines, transformer bushings. In daily life, we are just see it on the roadside, on our street, and like that we are see this transmission and distribution lines, right? At every time, that black color teacup like things are appeared. It is a ceramic material. It is insulating material. Hmm? Just if you are observe the transformer, on the top of that the bushings are there for high voltage and low voltage windings. It is also this type of ceramic materials insulators. You can observe this while passing the road or anything. Okay, right. Isolators, plugs, sockets, and fuse units. Fuse, if you are observed, fuse, that biscuit color, cream color material is there, very hard and strong. That is ceramic material. That is insulator. Telephone insulators, heat resistance elements in heating applications. Discs for electric stoves, electrical kettles to insulate heating conductors. High temperature applications like furnaces, equipments for high frequency systems where thermal shocks and resistance is desired. Capacitors and transistors, like that. So many applications are there. So many. Let's see some applications. Porcelain insulator and line insulators. Alumina. Alumina oxide is Al2O3, is known as alumina. These are all are porcelain, alumina, steatite. All are comes under this type of ceramic materials. This is a formula for this alumina oxide, Al2O3. Let's see its properties. The specific gravity of this alumina is 3.2 to 4.2 gram per cc, and its operating temperature is 1800 degrees centigrade. Dielectric constant is 8 to 9.5. Resistivity is 10 to the power of 14 to 10 to the power of 16 ohm meter. This means it is having very high resistivity material. That's why there is no chance to pass any current in this. Low hygroscopy, chemical resistant. Low hygroscopy, high chemical resistance, high tensile strength. These are the different properties used observed in our alumina. This is one type of porcelain insulator. Right? These are the properties of this alumina. So what are the applications by observing these properties? It can withstand very high temperatures, right? So the applications, it is used in circuit breakers, high voltage circuit breakers, spark plugs, resistor cores, substrates for integrated circuits and power transistors. This is about the what is that, alumina. Now let's see the porcelain. Porcelain are basically clays and quartz embedded in glass mixture. When used as insulator, glazing is done, that is a thin layer of glass is glazed over the insulator. Properties. The specific gravity is 2.35 to 5 g per cc. Its operating temperature is 1200 degrees centigrade. Its dielectric constant is 5 to 7. Resistivity 10 to the power of 11 to 14 ohm meters. Low hygroscopicity and high chemical resistance. High tensile strength. These are the different properties observed in porcelain type of materials. So overall our porcelain is basically clays and quartz embedded in glass mixture. These are the application. Let's see its applications. Transformer bushings. So it is used as line insulators. It is used at low frequency application, as because of that here see that dielectric loss is very much high in this. That's why switches, plugs, sockets, fuse holders, like those type of applications are used by this type of porcelain material. It is used for making switches, plugs, sockets, fuse holders. So we are observed this alumina, after that porcelain. Now the next is steatite. All are coming under this ceramic family. This is the next number, that is steatite. It is a mixture of clay and talc. That is, it contains hydrous oxides of magnesium and silicon. Hydrous oxides of magnesium and silicon. Let's see its properties. Specific gravity is 2.5 to 2.9 gram per centicube cc. Operating temperature 1200 degrees centigrade. Dielectric constant 5.7 to 6.5. The resistivity 10 to the power of 12 to 10 to the power of 15 ohm meters. It is low hygroscopic. High chemical resistance. Specific gravity is 2.5 to 2.9. Operating temperature 1200 degrees centigrade. Dielectric constant is 5.7 to 6.5. Resistivity is 10 to the power of 12 to 15 ohm meters. It is low hygroscopic. So low hygroscopic means it absorbs moistures, all those things, it's very less. High chemical in resistance means it is chemical resistant. If any, until unless any hard acids or alkanes are poured, then only it will react. Otherwise, nature to atmosphere, that is normal pollution and normal chemicals, it never react. That is chemical resistance is strong and high tensile strength also. So these are the properties observed related to our steatite. So what are the applications for that? Insulators for high frequency and high thermal shocks. In previous, the applications for this porcelain, that is, see, these are the applications. It is used at low frequency applications. It is used at low frequency application. Because of that, their dielectric loss is high, right? The steatite is used for high frequency applications and high thermal shocks. These are the important porcelain material, ceramic materials, that is we are studied the alumina, porcelain and steatite. Like that, so many types of ceramic materials are there in the ceramic family. We are observed just few types. Titanite is there, quartz, like that, so many types. Mostly we are mostly used porcelain, steatite, aluminum, like that. Porcelain is used in just general distribution systems, and the steatite is used in transmission systems. After that, in solid insulating material, the next is glass. We are studied about the solid insulating materials. In that we are studied impregnated paper, mica, asbestos, like that. Just now we are studied about the ceramic material. After that we move to glass type of insulating materials. What is this glass insulation material? Glass type of insulating material. It is normally transparent, brittle and hard. It is insoluble in water and the usual organic solvents. Glass finds its use in electrical industry because of its low dielectric loss, slow aging and good mechanical strength. Glass has its limitations because it is not easy to manufacture and is dense and heavy also. So glass is a special type of insulating material. We all are well know about this glass. In daily life we are used glass and so many occasions. It is very healthy also to use glass instead of this aluminium, plastic type of jars or materials like that in our food storage and essentials, like that. So glass is very good properties comparative with the remaining, but it is very difficult to maintain because of that, and the manufacture also it is difficult, and its density is also very much high comparative with the other. So what are the applications? Molded devices such as electrical bushings, fuse bodies, insulators, capacitors, radio and television tubes, laminated boards, lamps, fluorescent tubes. See, every lamps what we are used to, every lamps, infrared, metal filament lamp, tube light, all the materials are used by using glass only. Right? The lamps, fluorescent tubes, and some type of laminations also. Because of that, it is transparent in nature, right? That's why it is very easy to visible the light also. So every time we are choosing the glass for those type of, especially in lightning conditions. And it is used for capacitors, radio and television tubes, fuse bodies, some type of electrical bushings, like that we are used glass. It is very hard, but at the same time it is brittle in nature also. But the plus point is its aging is very less. So up to now we are studying the solid insulating materials like fibrous material, and after that impregnated, that is impregnated paper, impregnated mica, like that. After that we move to the ceramic materials, and mineral materials also we are studied, mica and mica products, marbles, asbestos, like that. After that ceramics we are studied the porcelain, steatite, aluminium, like that. After that glass material also. So these are all are coming under the solid type of insulating materials. After that, the next is what we left over, the another insulating material comes under the solid insulation material family. That is very much important. Daily life we are used, for every cables we are used around that. That is nothing but PVC. So let's see the plastic type of insulating materials. Right, plastics. Mostly we are used this type of insulating material because of that it is very easy to manufacture also and to maintain also, and transportation economically, so many advantages. So what are these plastics? Plastics are basically hydrocarbons. The hydrogen and carbons are contain their components as hydrogen and carbons as contain their components. Essential plastics are found in nature, are called as natural plastic, while man-made plastics are called synthetic plastics, and they are classified accordingly, natural and synthetic. See, these are the classification of these plastics: natural plastics, synthetic plastics. Synthetic plastics is also thermosetting plastics, thermoplastics. These are the varieties. The synthetic plastics is made by human, man-made plastic. It is of two types, thermosetting and thermoplastics. After that, natural plastics. So insulating resin or plastic is an organic material and are found in many varieties. Because why it is very famous? Because of that it can be molded into a different shapes and different colors. See, we are using a different types of cables in our wiring also. Oh, house wiring, just observe. Sometimes we are see red color wire, yellow, black, different colors, different shapes. It is all are in the plastic form only. It can be molded into a desired shape during or after manufacture by the application of heat and pressure. And the thermoplastic is used very frequently in common terminology, even for material which are not really plastic. Most of the plastics are of organic nature, composed of hydrogen, oxygen, carbon, and nitrogen. So, what is this resins? Resins is a substitute word normally used in insulation technology in place of plastic. Plastic is available in molding powder, sheets, rods, tubes, films, and liquids. Plastic is light in weight, low cost, water resistance, and are available in different colors. That's why these type of plastics are very famous in our industry level, right? So we call it as resins or plastics. These are classified like this: overally natural and synthetic. Natural resins or synthetic resins, or natural plastic or thermosetting. So let's see what is this natural plastic or natural resins. So natural resins, they are available in nature and are derived from plant and animal sources. They are used in preparation of insulating materials. Simple purification or sometimes a little chemical modification is made in natural resins for use and electrical insulation. The example of natural resins are amber, wood resin, shellac, etc. Wood resin is used for paint and varnish applications, and also for the manufacture of mineral insulating oils. Shellac is also used for impregnation and the manufacture of mica. So these all are coming under natural plastics. The plastics obtained directly from nature, that is from either plants or animals, are called natural plastics. The properties of most of natural plastics are not very good from the point of view of their use as insulator. But a few still find application in our electrical industry. That is what? Amber, wood resin, shellac, like that. Okay. We don't know about this amber, right? So let's see what is this amber. This is example of natural plastic. We are studied now like that. So the source of ambers is fossil resins. So what are the properties? Its specific gravity is 1.1, melting point is 250 to 300 degrees centigrade, dielectric constant 1.5 to 2, dielectric strength 2.5 kV by mm. Used for insulating materials, various components of measuring instruments. This is the application for amber. So amber is used for insulating various components for measuring instruments. After that, what is the next? The next example is amber. After that, wood resin we are studied. So what is this wood resin? The source of wood resins, as the name suggests, is wood. What are the properties? The specific gravity is also 1.07 to 1.1 only, and the melting point is very less, that is 130 degrees centigrade. More than that the wood will fight, right? So just up to 130 degrees only it is okay. And dielectric constant is 2.5 to 3. Dielectric strength is 10 to 15 kV per mm. So what are the applications for that? It is used for thickening agents for manufacturing insulating oils. We are used the insulating oils in transformers. All are having so many applications for insulating oils, circuit breakers. For cooling purpose and insulation purpose, we are used some oils. So this type of wood resins are used for manufacturing this type of insulating oils. It is used for thickening agents for making in this insulating oils. So these are the some applications. That is, our wood resin is used for thickening the agents for manufacturing insulating oils. So we are studied the plastic, that is natural plastic. The examples we are getting as amber, wood resins, shellac. We are studied about this amber. After that its properties and applications. Next we studied this wood resin just now. After that, see one more, that is shellac. Shellac means the source of shellac are tropical trees. Shellac is we are getting from trees. So this is also very natural material, that's why it is called natural resin. Okay. What is this shellac properties? The specific gravity is 1.09 to 1.14 gram per cubic centimeter. And after that, Melting point is very less, 80 degrees centigrade only, and its dielectric constant is 3.7 to 7.8. Dielectric strength is 15 to 50 kV per mm. What are the applications? So this shellac is used in the manufacture of tapes and binding materials. So our natural plastics, that is natural resins, are coming from nature. These are having very less applications compared to with the synthetic resins or synthetic plastics. Because of that, its properties are not so much good. But still we are used in that some applications. The famous natural resins we are studied is amber, wood resins and shellac. These are not used as direct insulating material. Because of that, its boiling point, all those things are very less, and its moisture levels are also high. That's why it is used in indirect manner. See, for example, this shellac is used in uh, the manufacture of mica tape. Like that, wood resin, it is used in the manufacture of insulating oils. And this amber, it is also used in measuring components of measuring instruments. Like that, it don't have very direct insulating material application. Because of that, its properties itself like that. Anyway, it's come from nature. That's why it is called nature resins. After that, the synthetic plastic is coming to picture. The synthetic resins are made by the chemical reaction of simple organic compounds. These resemble the nature resins in properties such as plasticity and heat resistance, but the chemical position is widely different from that of natural resins. Nowadays, more than 50% of the installation materials are synthetic resins only. Due to its economic and molded and different colors it is available, it is very cheap and light in weight, water resistance, like that, so many features it have. That's why 50% of the insulating material used in our industry, in our electrical industry, are plastics only. That is man-made plastic, that is synthetic plastic. So the plastic obtained by a chemical process called polymerization are called synthetic plastics. It's made by the chemical reaction of a simple organic compounds. Just it is also resembles as a natural resin, but in properties it is same such as plasticity and heat resistance, but the chemical reactions and this compositions is widely different from that of nature and no comparison at all. That's why all the properties are very much improved. These synthetic plastics are thermosettings and thermoplastics. Two types are there. So what are these thermoplastic resins and thermosetting plastic resins? So let's first observe this thermosetting plastics. Thermosetting plastics. These materials undergo a chemical change when molded. They are hard, rigid, and cannot be softened by heating to reshape them. The molding temperature for this material is higher than that of thermoplastic material. When heated first, they become soft, and on further heating, they undergo change and set hard. This process is called thermosetting. It is permanently set and does not soften on application of heat. If it is heated further, it will break down by burning. and fillers like wood, glass, glass fiber, mica, clay, magnesium oxide, aluminium oxide are often added in order to get desired properties. So the plastics which lost their properties when cooled after melting and cannot be reshaped. This is the main point you have to observe. Thermosetting plastic, it cannot be reshaped. If further heats, it is not softened, it will be burned. Just I will repeat the thing one more time. These materials undergo a chemical change when molded. They are hard, rigid, and cannot be softened by heating to reshape them. Why? Because the thermosetting plastic resins, it is requires very high temperatures than of thermoplastics. When heated first, they become soft, and on further heating, they undergo change and set hard, and this is permanent. Permanent we have to state. Otherwise, if we give the heat to change further application, then it will be burned. It will break down by burning. So it is set for one time. When cooled, melting and cannot be reshaped. So what are the properties? And what are the examples for this type of the various type of thermosetting resins are bakelite, silicon resins, epoxy resins are the examples. Let's see what are the properties. It is made by condensation, polymerization, cross-linked chains of molecules, hard and rigid, higher molecular weight, low hygroscopicity, good dielectric strength. What are the applications? Industrial moldings, reflectors, radio TV cabinets, adhesive varnishes, wire and cable insulators. This is about the thermosetting plastics. So up to first time heat, it is melt. After that we are giving some shape to that, right? After that we cooled it. Once cooled it, it never be give any reshaped. Because of that, it never accept any further thermo temperatures. Because of that, for molding itself, it requires very high temperature. So we molded for a shape. After that we cooled it. After cooled it, that is permanent setting. We are unable to change it further after cooling and cannot be reshaped. It cannot be reshaped. If we further giving any temperature, it will break down and further it will burn itself. So these are the properties and these are the applications. Industrial moldings, reflectors, radio TV cabinets. Just now, in your home also you are observed this type of plastic. A TV is there now. That complete cabinet is made fully. It is making with this type of thermosetting plastic itself. Observe that insulating material. That's why if we touch the TV, we are not feel any shock. Adhesive varnishes, wires and cable insulators, like that. It has so many applications. After that, thermosetting. The next is thermoplastic. The thermoplastics means uh, these are formed by polymerization process in which molecule of a compound react together to form new compounds. They can melt and soft when heated and solubility when cooled. The heating cycle can be repeated without any change in the property of material. Means it is recyclable. They are produced artificially from organic substance like oil and coal products. Uh, Fillers like mica, textile, wood, glass, fibers are often added in order to get certain desirable properties. Pure plastic, these materials are, it is not easy to make the material. Some impurities will be added. So these are called fillers. So what are the fillers we are used here? Mica, textile, wood, glass fibers are often added in order to get certain desired properties. So they are widely used for floor tiles, walls, fluorescent light, reflections, lenses, etc. So overall, what is this thermoplastics? It is recyclable plastics. They can melt and soften when heated and solidify and when cooled. But in this case of thermosetting plastic, when once heated, after that, if we give any shape, after that it will cool now. If we give further any heating, then simply it will burn or break down. It never came its original properties. It is not recyclable. But here, this in the case of thermoplastic, this thermoplastic is recyclable plastic. They can melt and soften, and when heated and cooled one more time, solidify that, the heating cycle can be repeated without any changes in their original properties. Okay, so what are the examples for this type of thermoplastic resins? Perspex, polyethylene or polyethane, polyvinyl chloride. So these are widest applications in our electrical engineering. That is PVC. Most of wires and cables all are made with this type of PVC. This thermoplastics mostly. So almost all the cables we are used in our house wiring and the level of transmission and distribution, whatever the cables we are used in, undergrounded cables like that, so many types of applications. Most of these wires are used with this PVC. Because of that, it is recyclable. It never changes its properties. So many times we can burn it, after that we soft it, after that we molded and made some material, we cool it. One more time if we harden it, and it will burn, it never burn or break downs. It will one more time, the heating cycle can be repeat without any change in its original properties. So what is its properties? It is made by additional system of polymerization, no cross-linked chains of molecules. It is less flexible, but mechanically it is very stronger. So low molecular weight, highly hygroscopic, poor dielectric properties. These are the properties for our thermoplastic materials. The examples are perspex, polyethylene or polythene or polythene cover is also this type of thing only. And polyvinyl chloride, PVC. This is very cheap and at the same time recyclable plastic also. So most of the world use this type of plastic. It is highly polluted, but due to its properties and its cheap cost, all those things, almost over 50% of applications are used this type of thing only. The insulation materials, ceramic and glass, asbestos, all are having very outstanding performances, mica, all those things. But this is very cheap comparative with those, and it's very flexibility for molding and give so many colors, and um, it never absorbs any moisture, water resistant, and very cheap in cost and light in weight. So many advantages. That's why all are going with this type of plastics only. But this is very danger to our human beings and animals, creatures living in our world. Because of that, it never mixed with our soil. That's why the pollution comes into picture. It is another subject, let's leave that. But this is our subject to talk about this insulating material, about this plastic, right? It is having much more applications comparative with all other application. This is the highest thing. Most of the insulating materials are this type of thermosetting and thermoplastics. Mostly we are using this thermoplastics. This is man-made plastic. It is not in nature. The nature plastic is also there, but it has very poor properties. That's why it is used in very less applications. The synthetic plastic is having more applications comparative with the remaining. Okay, these are the things coming under our solid type of insulating materials. In our next class, we will see some more insulating materials and its properties and applications. Thank you, and thank you for watching this.